Okay, so this is officially the last session of the workshop, and I sincerely hope that you have liked this workshop and have things to carry home. So this session is a panel discussion session, and we have three experts here, all of you whom you have met. The objective of this session is to hear from our panelists about or regarding the workshop theme in general. So you have heard their talks, you have learned several things from them, and so I thought that's probably a good time for you to interact with them regarding more details about their field of work. Particularly for PhD students, you all might be interested in knowing future directions of research in their respective fields. MSc students would obviously be benefiting from the fact that they will get to know what things are there to do. And then maybe when you go on to do your PhD, you might be interested in working in all of these things. The way that this session would work is basically each of them would spend some time discussing a few things, which obviously is beyond or goes beyond their talks, and then we'll have the floor open to all of you to ask questions, any kind of questions, your academic feedback on this workshop, and so on and so forth. Okay? So the session is supposed to be a very interactive session, so feel free to ask whatever questions that you have regarding their work, regarding the workshop, their talks, future research directions, and so on. Okay? So I'll first like to invite Professor Klein to tell us things in this regard.
Okay, so thank you. So before I start, I want just to thank all the organizers for this very nice workshop. It was my pleasure to be invited here to give my lectures. So I think there's something in mathematics that would be maybe the future of the research in statistics. Is the link between statistics and geometry. So it's something I didn't present here, but it's a subject I'm working in. Well, the reason of that is because nowadays we are having in hands data that are more and more complicated, and the data they lived in a space that are not vectorial spaces. Okay, so they are not flat spaces, so the geometry is very complicated. So one of the important things I think is to learn the geometry structure of the data in order to can build some distances that are the good distances in the spaces. Okay. So I think that if you are looking at a good area of research, I think that is it will be the future of research in statistics in the next decade. And I can do some advertisement that there will be a thematic semester in next year in Toulouse that will start in September, next September on the subject. So if some of you, if you are interested, I can give you the address of the website, and you can have some information about that workshop. Okay. So if you have any remarks concerning my lectures or other things, please.
Queries, questions that you would like to address to Professor Klein?
If you don't speak, we are not going to have much discussion. Yeah. So I think you have to come forward to speak.
Feel free to ask anything that you want to.
My experience tells that if one word or someone starts speaking, then a lot of people will tell. The question is who will come forward. Sure, Shweta.
Yes, sure.
Could you Right. Yeah. So could you tell us more about, say, the funding opportunities there for PhD, or say for the summer internships, people who want to go outside and explore the subject, maybe statistical analysis or mathematical modeling, things like that?
So, so there's something. Maybe I can write something on the blackboard. Yeah. So, for example, there is something that is called. So it's an international center for mathematics and informatics that is in Toulouse, and they have each year they have a call, where they have I think something like 4 PhD grant, and I think they have 2 postdoc positions each year. Okay, so they have a website. In the website you can find the applications deadlines. Okay, so each year you will have. I'm not sure about the number of grants they have, but something like that. And then each professor they can have some grants, but that's changed every year. So there is no rules. Okay, so for example, I have 2 grants for next year, but they are a PhD that will take place in some industries. Okay, so they will be very applied PhD, because in France there's a lot of PhD that are done into firms. Okay, so they are in the firms, they are working on research projects, but they are very applied research projects, of course. And they have a PhD director that is a professor in the university.
Yes, please. What are the results?
What are the research topics that are going on in Toulouse? Means in your universities, yeah.
What are the research topics
that are yeah. So
the Center of Mathematics of Toulouse is
can you give in detail something?
You have everything. Anything you want. It's the Institute of Mathematics of Toulouse. It's 200 permanent researchers. Okay, so it comes from the pure mathematics to applied statistics. So you want to do algebraic geometry. There are some people that are doing it. You want to do partial differential equation. They are very strong. You want to be a probability. I don't know. Functional inequalities. What you want, I think you can find in Toulouse. So it's a very usual university in Toulouse. So you have all fields in mathematics.
Maybe I'll try to get something going. So you said that. So you said that one of the big research directions or future topics of research would be to look at the interplay between statistical methods and how geometry has a role in shaping statistical methods. Could you slightly give a few examples or elaborate a bit?
Yeah, well, I have a speech on that if you want, but
yeah,
my computer.
Sure, please. You want to use your laptop?
Oh, I can explain on the blackboard.
You can just spend a bit of time on the board. Yeah.
Oh, it's there. Okay.
This could not put just.
So let me explain the problem, okay? When you are on the straight line, okay, what will be the middle of the 2 points, or the mean of the point A, B? Okay, it's very easy. it will be that point, okay? Now, if you are not in a vectorial space, okay, imagine now that you are on the circle. Okay, so now, if you don't know the geometry of your space, okay, and you want to compute the middle of the point A and B, it will lie here, and this point is not on the circle, okay? And that's a problem because you are not anymore in the space where you should be, okay? What do you want here? You want to find something that tells you that your middle point is here, okay? Can give you another example. Imagine that your data are density functions, okay? Imagine you have two Gaussians. Okay, so now what happens if you do the mean as if you are in a vector space? You will find something that is I think it will be something like that. Okay, and this is very strange because what you have two Gaussians, and the mean of two Gaussian is obviously not a Gaussian. Okay, you don't want that. Okay, you want that if all your data is Gaussian, when you do the mean, you want to find something that is a Gaussian. Okay, where would you? So intuitively, what do you want to obtain? You want to obtain a Gaussian that would be more or less exactly in the middle of your two Gaussian, okay? So, what is happening? Do you remember? I talked, I think it was the day before yesterday, there was two ways of defining the expected value. There is one that was the point that was minimizing. Okay? What are you doing? This is what this is. In fact, this is the Euclidean distance. Okay, when you do that, is that you are finding the point that I'm minimizing all this distance with respect to the Euclidean distance. Okay, but now you can change the distance here. Okay, so what happens here? If you take the geodesic distance on your sphere, and you do exactly the same thing, but here you take the geodesic distance. What you will obtain here is this point. Okay? And now what can you do if you want to find here this curve? You replace the Euclidean distance by, for example, the Wasserstein distance. So that would be the Wasserstein distance. Okay? If you do that, and you do the humanization problem, you will exactly find this Gaussian, okay? But now when you are on a space that is not a vector space, you can have so we all know that sometimes the mean value does not exist, okay? But we know that in R, if it exists, it is unique, okay? If your space is not anymore a vector space, this is not the case, okay? Imagine you take the north poles and the south pole, okay? What will be the median or the mean value? It could be that one, this guy or this guy, okay? So here the problem, you don't have unicity of the mean value, okay? So if you know the geometry of your space, you can find a good distance. And then you can know what the mean value is, and then you can do a perform statistic. You can do maybe PCA. You can do all this kind of thing. If you do PCA with density function, considering that they live in L2, you will have something that is very not good. Okay. Yes. Sorry.
Extended real number line. In extended real number line, so R union infinity.
Yes.
In that, do you have a unique mean?
Yes. Yes. Yeah.
But you can identify that with a circle. So in a circle, you said we don't have a unique mean. So can we do that?
No, because in R bar, minus infinity and plus infinity are not the same points. In a circle, you have the, in some sense, you are putting the two infinity in the same point. Okay. If you do the stereographical projection of the circle on the line, you are minus infinity and plus infinity will come to the north pole. Okay. So it's not the same. This is not R bar. Okay.
Any other question? Okay. So if we have no other questions for Professor Kla, I hope you have understood most of the things and have appreciated these things that he has said. Okay, so let's thank Professor Kla once again for coming here and spending time with us and teaching us several things. Now I would like to request Professor Ashok Nanda, our own, to say a few things, and I'd like to, I think, say a few things regarding a completely new topic.